Question number 4, this will be for 11 marks. Okay, so 11 goes 7 minutes. An electric heater, a heater in an electric shower has a power of 8.5 kilowatt. Power is given when connected to a 240 volt electrical supply. Voltage is given. It is connected to an electrical supply by a power cable. The following data is available. Length is given, cross-sectional area is given, and then resistivity of copper is given. Everything is given to you. Okay, calculate the current in the cable. So how do you calculate current? Use the formula. Use the formula P is equal to V into I. Right. So what is I here? You need to find I should be equal to P divided by V. What is P? 8500. Where did I get? I got from here 8.5 kilowatt divided by voltage 240. When I do this, what is the answer I get? Use your calculator to get the final answer. 8500 divided by 240. You get the answer as 35.41. Since we have only two significant figures, give it as 35 amperes over here. Okay, 35 amperes. Now let us move on to the next one. Next one says calculate the resistance of the cable. How do you find the resistance of the cable? Look at this, you have L, A, rho is given. Okay, so what you can do? You can use the formula for resistance, which is rho L divided by A. Now substitute all the values. What is rho here? Rho is 1.7 into 10 power minus 8. 1.7 into 1.7 into 10 to the power of minus 8 multiplied by what is the length over here? Length. What is the length over here? Length is not known. Length is given here. 10 meters. 10 meters divided by 5 into what's the value of R? Radius. Radius is given. Oh, cross-sectional area itself is given. What we do is, let us remove this one and just write 6 millimeter square. 6 millimeter square. Let me convert this. So this should now be equal to 1.7 into 10 to the power of minus 8 into 10 should be 10 power minus 7 divided by 6 multiplied by millimeter square is 10 power minus 3 whole square, which should be 10 power minus 6. Thus, this will now be 1.7 by 6. How much is it? Let us calculate that. So it should be 1.7 divided by 6. Should now be 0.28. So this should be 0.283 into 10 to the power of minus 1, which should now be equal to 0.028 ohms. Resistance is ohms, right? So you got this answer also. Next, calculate the power dissipated in the cable. What is the power dissipated in the cable given by? See, there are two powers here. The first one is the power which an electric shower has a power. The second one is, in order to have this electric shower, there are some cables attached to it. Okay, what is the heat which is being dissipated on the cables, right? So definitely when you switch on your geyser or your this one, okay, you see that the wires will get heated up. You need to find out that wattage. So which should now be equal to the current which is flowing through it, I square multiplied by the resistance of the cable. So what is the current flowing through it? See, resistance is 35, current is 35 amperes. So this should be 35 square multiplied by 0.028. So let us calculate what is this value, which should now be 35 star 35 star 0.028, which should now be 34.3, or nearly 34 unit is watt. So the power dissipated is 34 watt, okay, which is coming out as a heat energy. Then next, explain in terms of electrons what happens to the resistance of the cable as the temperature of the cable increases. Now power we have seen. Now because when we have a power over here, what will happen? The temperature rises. When the temperature rises, what happens? Automatically, in terms of electrons, it's asking. So if you ask me that directly, you can say resistance will increase. But for how many marks is this? This is for, just let me see, for how many marks? For 3 marks. So definitely you need to write 3 points. Okay. When temperature increases, what happens? The collisions between electrons also increases. When collisions between electrons increase, what happens? The drift velocity will decrease. It will not move faster, right? It's something like you are in traffic, in a road, in a vehicle, okay, and there are a lot of collisions, there are a lot of what you call traffic jams. Because of traffic jam, what happens? There's a possibility that you can go and hit one vehicle with the other. When something like this happens, then definitely your vehicular speed will be reducing. When this reduces, then what happens? The current will also reduce. Why should current reduce? Because I is equal to NEAVD, right? Directly proportional to the drift velocity. When V reduces, definitely I reduces. When I reduces and voltage remaining constant, what happens to resistance? Resistance hence becomes R equal to V by I. So this implies R will increase. Okay, do not write directly this one, you will only get 1 mark. Okay, because he is asking in terms of electrons, he is not asking you, okay, what happens to the resistance. So you should now navigate all these steps and finally mention this. Okay, next, the heater changes the temperature of the water by 35 kelvin. 35 kelvin. The specific heat capacity of water is 4200. P is given. Determine the rate at which the water flows through the shower. State an appropriate unit for your answer. Now you see, we are now talking about a thermal physics problem. Okay. Now we know that in thermal physics, the energy required to increase the temperature of a water by delta degree Kelvin or centigrade is given by E is equal to mc delta T. For those who have already studied about thermal physics, you might be knowing this one over here. Now what I do is, if I divide this by time, what is this? This is energy, right? If I divide this by time, I'll just say E divided by T is equal to mc delta T divided by T. Okay, I'm just dividing by T. So what is E by T? Energy by time, power. Power should now be equal to m divided by T. I'll group these two together, multiplied by C into delta T. Okay. Now what is he asking here? Determine the rate at which the water flows. Water flow can be calculated in terms of volume per second or in terms of kg per second, mass per second. So here I already have a mass per second. Okay. So therefore I will use this one as a subject and I will write m by T is equal to P divided by C delta T. Bring this two downwards. Now what is P? P was already given over here. Where was CP here? P was somewhere over here, right? P was seen to be 8.5 kilowatt, right? That was the power given to it. So therefore, use that power and write this is 8.5 into 10 cube divided by what is C? 4200. What is delta T? 35. When I do all this, what is the final answer I get? I go back to this and now I will type this as 8.5 divided by 4200 is equal to so much divided by 35. When I do this, I get 5.78 into 10 to the power minus 5. 5.78 into 10 to the power of minus 5 multiplied by, see, I left this 10 cube. I write this 10 cube over here, so which should be 5.78 into 10 to the power of 10 to the power of minus 2. What is the unit? Kg per second, right? So much. Let me check my answers over here. See whether we are doing it correctly. Yes, we are getting the same answer. Or in other words, I can now write this as equal to 0.10 power minus 2, right? I'll put 10578 kg per second, 0.0578 kg per second or 0.058 kg per second is the right answer. Okay, so kg per second is the unit. So remember, you are supposed to write all the steps properly, only then you will get a full mark for it. Okay, so with this we come to an end to this problem and tomorrow we will start with a new problem. Thank you. Before leaving, do like, share and subscribe to my channel. Share it with all your friends so that I also get an encouragement to do much more future videos with you. Thank you.